Okay, in this video, I'm going to go over the Unit 3 test review. So again, we got to name all our postulates. So we've got side, 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 angle, side, angle, side, angle, 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 side, and HL. Then we're going to work through these drawings. So this says decide whether it's possible to prove the triangles are congruent. If it is possible, tell which congruence postulate or theorem you would use. If it's not possible, write not congruent. We're just going to put the symbol. But here we have side, side, angle. So this is definitely not congruent because we don't do that with two sides. We have to have an angle between them or two angles. This one, we have a shared side and another right angle there. So you should see that we have two right angles, and those are our hypotenuses right there. And we have another leg. So this one's going to be HL. Going to mark our vertical angles on this one, and we should see side, angle, side. On this next one, we have that these sides are parallel. That's what those arrows mean. So we can mark that that angle is congruent with that one because they're alternate interior angles. This angle is congruent with this one down here because they're alternate interior angles. And then we've got our pair of vertical angles, which we could mark this either because they're third angles or because they're vertical angles. The problem with this one is we have no sides. And if we have no sides, we cannot prove congruence. So this one's going to be another one where we don't know if they're congruent or not. So we can't say that. On this next one, we have, again, these parallel symbols. The arrows on the sides mean parallel. So we could say that this angle is congruent with this one because of, again, alternate interior angles. We could say that this angle is congruent with this one for the same reason. And then we do have our third angle here, vertical angles, again. So this one actually has two. So when we talk through this one, we have angle, side, angle here. So it could be angle, side, angle. Or it could be angle, angle, side. So either one of these is true. All right, so number 7 is side, side, side. Number 8, I'm going to mark 3 ticks on that shared side. Again, this is side, side, side. And number 9, notice that we have this part right here that's shared by both. So if that's this part right here is shared by both, so that means this length, because there's a tick mark here and there's a tick mark here, then all of this would have to be equal to all of that. So that means those sides are congruent. So then that would be side, angle, side. So number 10, it says DC is parallel to FG. What else would you need to know to prove that triangle DCE is congruent to FGE by angle, side, angle? On this one, because these sides are parallel, we can say that angle C is congruent to angle G because they're alternate interior angles to each other. We can say that D is congruent to F because they're alternate interior angles to each other. And then we can say that CED is congruent to GEF because they're vertical angles. Now, because of that, that means that we could have said any pair of sides were congruent. So we could say that DC is congruent with FG. Or we could have said that CE, going from 1 to 3, is congruent to GE. CE congruent to GE. Or we got one more choice we could have done. We could have said DE is congruent to FE. And remember, when you're writing these statements that you want to go from, like when I did DE, I went from 2 arcs to 3. So when I say FE, I'm going to go from 2 arcs to 3. Number 11 says, what else would you need to know to prove that triangle DEF is congruent to MNO by side, angle, side? We're given some pieces of information on this, and we're going to go ahead and mark those. It says FE is congruent to ON. It also tells us ED is congruent to NM. That's this one. And then it says we're supposed to prove that these two are congruent by side, angle, side. So side, angle, side means the angles between the sides. So we want to go ahead and mark that angle that we're going to talk about. So that would be it. That's now side, angle, side, and side, angle, side. So it would mean that angle E would have to be congruent with angle N. So number 12 says, what else would you need to know to prove that triangle DEF is congruent to MNO by angle, angle, side? This time we're given some different information. So we're given that angle D is congruent to angle M, and we're given that DF is congruent to MO, and then that means we need another angle. So it means we need an angle next to the angle. So we would need this angle up here, E, then it would be angle, angle, side, and N, which would be angle, angle, side again. So that means we need to know that angle E is congruent to angle N. This number 13 says, what else would you need to know to prove that triangle DEF is congruent to MNO by side, side, side? So on this one, we're going to mark what we're given. We have DF is congruent to MO, so DF is here and MO is there. Then we have FE is congruent to ON. So this time we just need the third side. And the key here again is going in the same direction. So I'm going to give you all a little trick here. Because we have the statement right here, we've got DE, the first two letters here, so it would be MN, the first two letters there. So we can say that DE is congruent to MN. Okay, so with number 14, it says angle I is congruent to K, IJ is congruent to KH, and J is congruent to H. So we're going to go ahead and mark these in the drawing. So I is congruent to K. Then it tells me that IJ is congruent to KH. Oops, I did that wrong. Sorry. IJ is congruent to KH. And then we have that J is congruent to H. So we got J is congruent to H. So it says name the congruent triangles. So what I'm going to do is I'm going to name these by just looking at my arcs. So I've got 1 here, 2 here, and none there. So I'm going to say IJL, IJL. And so what I'm going to do over here on the right is what I did on the left. So I'm going to go 1, 2, none. So that's going to be KHL. And then how are these congruent? What do we have? We have an angle, a side, and an angle. So that is our congruence. So number 15, by the way, there was no F. So letter A. So let's find A. We've got A down here. Well, first of all, I know that this is a right triangle. It says that given the two triangles are congruent, find the missing side lengths. Okay, so what I'm going to do is I'm just going to basically take everything from one triangle and put it in the other. So this is 48 down here, so this is 48 right here. I got my 11.2 here, so this is 11.2. I got my 42 here, so I've got 42 there. I've got 7 feet here, so I got 7 feet here. So by transferring all of one to the other, that is going to enable me to just go ahead and fill in my blanks. So A was 7 feet. B, where's B, is 42 degrees. C is 90 degrees. D was 48 degrees. And E was 11.2 feet. Number 16 says, explain how you know the triangles are congruent and then solve for x. Okay, so I'm going to put 3 tick marks here because that's a shared side. So we know these are congruent by side, side, side. That's the first thing we want to say. Then we should be able to see that this side has 2 ticks and this side has 2 ticks. So those can be set equal to each other to solve. So we're going to say 7.5 is equal to 1.5 plus 2x. We're going to subtract the 1.5 from both sides, so that's going to give us 6 is equal to 2x. Divide both sides by 2, so x is equal to 3. And that's all we were solving for. Now if it asks us for the side, and the way we could check this is to multiply 2 times 3, which is 6, and add 1.5 to that. That's 7.5. All right, now let's talk about number 17 because I had lots of people asking me questions about this. Want to see if you guys notice that these two angles right here are congruent, which means that this one right here is also 5x minus 4. Now, hopefully you recall that when we add together these two remote interior angles, they equal our exterior angle, this one out here. Okay, so what we're going to do is we're going to add 5x minus 4 plus 5x minus 4. We're going to set that equal to 8x plus 4. Going to combine our like terms here, so that would be 10x and negative 8 equals 8x plus 4. I'm going to subtract 8x from both sides. That's going to give me 2x here. And I'm going to add this 8 to both sides. That's going to give me 12. So x is equal to 6. Notice that it asked me for the measure of RST. So that means I have to put that 6 back in the equation. So we're looking for the measure of angle RST. We had the equation 8x plus 4 for that. So I'm going to go ahead and plug that 6 in there. So that's going to be 8 times 6 plus 4. 8 times 6 is 48 plus 4 is 52. So the measure of angle RST is equal to 48 plus 4. That's 52 degrees. Remember, by the way, that number 17 is the exterior angles theorem. So number 18 says the polygon D, E, and F undergoes the transformation xy to 3x, 3y. It says name the coordinates of the image points and state the transformation. Are the figures congruent? I don't know why that's there twice. And then give a detailed explanation as to how you found this answer. Okay, so we have to first recognize that this right here is a dilation. When we multiply that 3 attached to the x and the 3 attached to the y means that it's being multiplied by. So what we're going to do for D, which was 1, 3, we're going to go that 1 times 3. Let's do it this way, just to make it clearer. I'll put it in parentheses. 1 times 3, and then 3 times 3. That's going to be my new D prime. So that means D prime is going to be 3, 9. Then we've got E, which was 1, negative 2. We're then going to multiply all of that by 3. So we're going to do 1 times 3 again. We're going to do negative 2 times 3. So that's going to give us for E prime, 1 times 3 is 3. Negative 2 times 3 is negative 6. And then we've got F, which was 3, 0. So here again, we're going to multiply 3 times 3. And we're going to do 0 times 3. So 3 times 3 is 9. So that's our F prime. And then anything times 0 is 0. So now it says, name the coordinates. That's what we did. So this is our answer over here. These are our new coordinates after we've transformed them. And then it says, are the figures congruent? Well, if we made it 3 times bigger, then obviously the figures are not congruent. So we're going to say no, they're not congruent. And then it says, give a detailed explanation as to how you found this answer. I'm going to say, multiplied all x's and y's by 3. And we know this was a dilation by a scale factor of 3. All right, number 19 says two angles of a triangle measure 55 and 82. What is the measure of the third angle? Give a detailed explanation as to how you found this answer. Well, what I know is when I add 3, this is the Triangle Sum Theorem. That's what this would be. And then when I add 3 angles together, they have to equal 180. So I'm going to say 55 plus 82 plus the measure of angle 3, that's got to equal 180. So 55 plus 82, that is 138, plus the measure of angle 3 equals 180. So we're going to subtract the 138 from both sides. So the measure of angle 3, let's see if I can do this in my head, is what is that? Let me do it over here, y'all. .42 degrees. See, even I can do subtraction the old way when I don't have a calculator. So number 20 says, what is the value of x if the acute angles of a right triangle measure 4x plus 3 and 2x minus 9? Now, I want to go ahead and draw this for y'all because some of y'all will do better if you have a visual representation of this. It says it's a right triangle. I know that one angle is 4x plus 3, and I know the other angle is 2x minus 9. So this is, again, the Triangle Sum Theorem. And I'm pretty sure you're going to have to write that on the test. There's a couple ways I can do this. I could say that 90 plus 4x plus 3 plus 2x minus 9 equals 180. Or I could just start out by saying that these two have to add up to be 90. So I could have said 90 equals 4x plus 3 plus 2x minus 9. And I like to do things the shorter way, so that's exactly what I'm going to do. So 90 is equal to 6x, 4x plus 2x is 6x. And then we got 3 minus 9, that's minus 6. So that's going to be, now when I add 6 to both sides, that's going to give me 96 equals 6x. And then when I divide 6 into 96, x is going to equal to 16. Now if it asks you for the actual angle measures, you're going to have to put that 16 back up in. So 16 times 4 is 64 plus 3 would be 67. So this angle right here would end up being 67 degrees. And then if I do 2 times 16, that's 32, minus 9 is 23. And that's a good check for us anyway, because when we add those two together, they should equal 90. And if they don't, then we got the wrong answer. So number 21 says, what are the two ways you cannot use to prove that triangles are congruent? That would be angle, 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 or side, side angle. Remember, you can't have two S's together unless there are 3 of them. Number 22 says, if A, B, and C are collinear and B is between A and C. Now, y'all's original review had between A and B, but it should be A and C. So this right here should be changed on y'all's review. It says, and A, B is, okay, so let's just draw this first. So we've got A, B, and C are collinear, and B is between A and C. So I'm going to draw me an A here and a C here. And I'm going to put B between. Now, I don't know where, but somewhere between. Doesn't matter where. Now we have this part right here. It says AB is equal to 4x plus 2. And it says BC is equal to 6x minus 4. And oh, by the way, it also tells me that the whole thing, AC, is 48. So this would be the segment addition postulate that we're using here. The segment addition postulate. This takes us way back, but we got to remember everything. So that's what we're using here is the segment addition postulate. So aren't we going to add part plus part to get the whole? So we're going to say 4x plus 2 plus 6x minus 4 equals 48. So that's going to be 10x, because 4 plus 6 is 10. And then 2 minus 4 is a minus 2. So that's going to give us 10x equals 50, because we're going to add 2 to both sides. And so when we divide 10 into 50, we get x equals 5. That is not the ultimate answer. It says what are x and BC. So x was 5, true. But then we have to plug that back in to get BC. So BC is equal to 6x minus 4. So we're going to do 6 times 5 minus 4. That's 30 minus 4. So BC is equal to 26.